Dynamic programming playlist. Dynamic programming playlist. खतरनाक latency. Dynamic programming playlist. Dynamic programming playlist. Yeah. It's working now. Huh. So let us start. The question is Geeks training, or also known as Ninjas training. So a geek is going for a training program for N days. He can perform any of these activities: running, fighting, and learning. Practice. Each activity has some point on each day. As geek wants to improve all of his skills, he can't do the same activity on 2 consecutive days. Given a 2D array of size n, where ARRI 0, ARRI 1, ARRI 2 represent the merit points for running, fighting, and learning on the ith day, determine the maximum total merit points the geek can achieve. So let me delete the comments. So let us try to understand this with the help of an example. Okay, so let's take the current example, which is 1 2 5 3 1 1 and 3 3 3. So this is day 0, this is day 1, and this is day 2. So according to the question, if the ninja or the geek, if he performs any activity on a particular day, so this on a particular day he can perform any of 3 tasks. So he can either perform task 1, task 2, or task 3. Right, I'll just number it. This is task 0, this is task 1, this is task 2. So he can perform either of the tasks. So if he performs task 1, he gets 1 merit point. If he performs task 1, he gets 2 merit points. If he performs task 2, he gets 5 merit points. Similarly, on day 1, if he performs the same activity, he gets 3 points. If he performs task 1, he gets 1 point, and if he performs task 2, then he gets 1 point. So our job is to, like it says in the question, as the geek wants to improve all of his skills, he can't do the same activity on 2 consecutive days, which means if I perform, let's say, task 0 on day 1, then I can't perform the same task on the second day. And if I perform, let's say, task 1 on the second day, then on task 3 I can perform task 0 and 2 but not task 1. So if we select, let's say, so our job is to find the maximum merit points that the ninja can accumulate at the end of day 3, provided that he can perform 1 task per day, and on the next day he can't perform the task that he performed the last day. So this would be something like okay, so if I perform the task 2 on day 1, I would get 5 points. On day 1, if I performed the task 2, I get 5 points. On day 2, since I can't perform task 2, I can either perform task 0 or 1. Let's take task 0 because that would give me a higher merit point. That would be 3 points, right? And on day 3 we can't perform task 0, so we either have to perform task 1 or 2. So let's perform task 2, which gives us 3 points. So in this case, the total points that we can get is 8 points at the end of day 3, right? So, but is that the optimal number of points that we can get, right? So as you can see in the explanation given in the example here, it says geek will learn a new move and earn 5 points, right? And then on next day he will do running and earn 3 points. Okay, 8. Yeah, it is actually 11. Yeah, so this is the maximum number of points that the ninja can accumulate from day 0 to day 2 without repeating any tasks that was repeated on the that was done on the previous day. So if we take the greedy approach, right, let's say on day 0 we will perform the task with the maximum points. That's what we did, 5 points. On day 1 we select the task with the maximum points, so we selected 3 from the available 2 options. And on day 3 we selected the maximum. Here all of the points are equal, so we could select any of them, right? But what if the example was different? What if let's say on day 0, task number 0 gives us, let's say, 10 merit points, right? And on day 1 the same task gives you 100 points. Let me space it out a bit. Yeah. So if we perform the greedy approach here, then on day 0, I would select the maximum points, right? The task that gives you the maximum points. So if I select task 0, I would get 10 points. But because of this, on the next day, I cannot select the task 0 again. So I have to select either task 1 or task 2. So the maximum of these two will be 1. And on the third day, since I selected task task 1, so I can either select task 2 or task 0 or task 2. So either this 3 or this 3. So I can select either. And my maximum points would be, my maximum points would be 14. Right? This is when we follow the greedy approach. But what if instead of taking 10, or instead of taking task 0 for the first day, we do task 2, and we would get 5 points. Then on day 2, since we cannot perform task 2, we can either perform task 0 or task 1. I would select task 0. It would give me 100 points. And on day 3, I could select either of the 3. I can't select task 0, so I have to select task 1 or task 2. So I select task 2 and I get 3 points. That would give me 108 points. Right. 108 points. So as you can see that following the greedy approach will not work all the time, right? Because the rate at which the merit points are increasing, it's not uniform, right? It varies for each day. So following the greedy approach will not work for us. So we have the only option for us right now is to try each and every possibility, right? Like I have to try task 0 on day 1, or task 1 on day 1, or task 2 on day 1, and similarly for the rest of the days. So the only way to solve such kind of a problem when we have to try always is recursion. So let us try that. So for recursion, the most important thing is we need to be able to write the recurrence relation, right? So how can we express this problem in terms of index, right? So what we can do is we can treat each day, right? We can treat each day as an index, right? On, let's say, day 0 is an index, day 1 is an index, day 2 is an index, day 3 is an index, right? And accordingly, on a particular day, we will perform some kind of task. So what we can do is, let me write a function which returns an integer. Let's call it f. So f will be taking obviously an array, and it will also be taking the day, and just taking day is not enough, right? Whenever we are going to perform a particular task on a day, we need to know what task was performed on the previous day so that I don't perform the same task today. So we will be taking something like a last signifies which task was performed on the last day. So what we can do is we can find out the number of days or the number of array elements in this 2D array. That can be done easily by using this method. So what we can do is we can return the function, we can pass. So what I'm going to be doing is I'm going to be starting from the nth day, like from day 3, then day 2 to day 1 to day 0, right? So let me pass the nth day. Because it's 0-based indexing, I'm going to be sending n-1, and since there are 3 tasks, task 0, task 1, task 2, and on the first day obviously no task was performed beforehand, so we can choose either of the tasks. So 3 is going to signify that no task was performed in the previous day, and then we're going to send the array. Now it's time for us to write the base case. So when will we reach the base case? It's when we have reached day 0, right? So if our day, which we are treating as the index, equals to 0, this means that we have reached the end. Now if we have reached the day 0, right, like let's treat this as day 0. I can't select this. Yeah, let's treat this as day 0. So let's say on day 1, right, on day 1 I selected 3, that is task 0. Then on day 1 I can't select, and this task 0 again. I have to select either 2 or 5. So what we can do is, since it's the final day, we can select the maximum of these 2 values. So that's what we're gonna do. So if day equals to 0, then what we can do is store the maximum of these 2 values. We can return. Okay, we also have to go through like a for loop, right? A for loop which goes from, let's say we'll call the for loop variable as task. The task can go from 0, and then since there are 3 tasks, it can go till 2, sorry. So task plus plus, but then we need to select a task which is not performed in the last day, right? So we need to make sure of that. We can put if task is not equals to the last task that was performed. What we can do is we can actually create a variable which stores the maximum, right? So maximum would be the maximum of all the values. So that would be maxi and ARR of task. No, it's a 2D array. So this would be day 0 and the task. Okay. So whichever is the maximum, that's what we're going to take. And then once we have it, right, once that is done, what we can do is we can return this maximum value. Okay, now this was the base case. Now we need to decide what we can do on the particular day, right? So on a particular day we need to select a particular task, so that's what we're going to do. Same way, we can go through all the tasks. task equal to 0, task equals to 3. This also has to be 3 because we are going from 0, 1 and 2. Then we can increase this value, and it's the same thing as previously done. If tasks not equals to last, then we can calculate the points, right? Points on a particular day. So if I select task 0, then my points would be ARR of day and a task. Sorry. This would give us the merit points for task on day 0, on day equals to day. And then from then onwards, what we can do is we can use recursion to go towards the next day, right? So since we are starting from the nth day, we go to the previous day. So we'll be passing day -1, and we'll be passing task, because for the next function this becomes the last day, right? This task becomes last here, which means this task was performed on the previous day. So we can do that. We can add this, and then we can use a maxi variable again, and so the maximum of this. So maxi equals to math dot maxi and points, right? And then all we can do is we can just return maxi. This would give us the maximum number of points that we can get on this particular day, depending on which task we performed, right? So I think this should be correct. Let us compile and run this to see if this works. Okay, there's some mistake. Line number 10. Array required but integer form. What do they mean? Array required but integer found again. Okay, I have. Oh, this needs to be ARR. I forgot to pass the array. Cannot find symbol points. Oh, sorry. This needs to be inside. We get the maxi. dot maxi, that's line number 10. I can't understand what's the problem here. We're taking the maxi of ARR 0. Oh, that's a big mistake. We are working on a 2D array, but we are just passing a 1D array. Yeah, it is working fine. As you can see, we can get the output in the expected output as 11. We can submit this, and it would fail because this is the recursive solution and the time complexity of it will be exponential, so we want to reduce that. So this is where we come to memoization. So what we can do is, if we draw the recursion tree, then we'll be able to figure out that there are overlapping subproblems. This means that when we go in the flow of the recursion tree, then we'll realize that let's say for solving for a particular day, right, we'll be able to store that value so that we can use it later again. Like, we don't have to go into recursion again, since its value has already been calculated at some point of time in the recursion tree. So what we can do is we can declare a DP array, and its size would be, if we think of the number of states for the days, we would need to store n number of days, that is 0, 1, 2 to n minus 1, and for each day there would be a task, right, 0, 1, 2, but we are also storing 3 to signify that no task was performed in the previous day, so we can use an n into 4 2D array. And obviously we will need to initialize it to -1. What I can do is I can use the arrays.fill method to make things easier for us. Arrays.fill, I don't know if Geeks for Geeks has this function, so I'm gonna manually write it. So this would be int j equals to 0, j less than 4, j plus plus, and dp of I j equals to -1. And then we're going to pass the dp array. Right, so here this is the base case. What we can do is, instead of returning maxi, we can store this value so that later if we encounter the same value again, we don't have to go into the recursion tree. We can just take the value from the dp table. Now this would not be ij, this would be on the particular day, and the last task was performed. So here what we can do is, if our dynamic programming table already has a value, that is if dp of day class is not equals to -1, right? If it's -1, this means the value has not been calculated yet, but if it's not -1, we Don't go into recursion, we just return the value. dp of day last. And then we also need to pass the dp array here, and yeah, I guess that should do it. Let us compile and see if we made some syntax errors. As you can see on Java line number 30, we did something. What did we do? Expected. Oh, forgot to put the new keyword. Not a statement. I'm making silly mistakes. I equals 0, I less than n, j equals 0, j less than 4. Is there anything else? 31, we are missing a semicolon. Let's compile and run this. Reach end of file, I think. We must have deleted a bracket somewhere. Maximum points. Wait, this is the bracket. Reach end file while parsing. Oh, this for loop was not closed. Find this. As you can see, the code is being compiled. Now I'll just submit this. Yeah. So the memoization solution is running, and the time complexity would be, let me just write it here. The time complexity of this solution would be, since there are n into 4 states, so it would be n into 4, right? No, the time complexity would actually be order of n, right? Because those are the maximum number of states, and space complexity would be, we are using again a recursion stack of n space. For storing the days, and then we are also using a dp array of size n into 4. So let me confirm this. Now the recursion tree would go up to n. That would be the time complexity, and the space complexity would be this. So what I want to remove is this particular n, recursion stack space. So this is where we try to move to the tabulation solution. So for the tabulation solution, all that we need to do is we need to convert the base cases of tabulation. So here what we can do is use the same DP array. We don't need to declare it as -1. Right? So the base case in memoization is that if it stays 0, then depending on the task that we perform in the previous day, we would select the maximum of the other 2 tasks. So that's what we're going to do. We are going to use dp of 0 if task 0 was performed on the previous day. Then we would take the maximum of task 1 and 2. ARR of 0, 1, that would give us task 1. ARR of 0, 2, that would give us task 2. Then dp of 0, 1, which means on day 1 the task 1 was done, so on day 0 we have to do either task 0 or task 2. So math.max ARR of 0, 0, that's task 0, and then task 2, that's 2. Similarly, we fill up the rest of the values. Math.max ARR 0, 0, ARR 0, 1, and dp of 0, 3, which means no task was performed on the previous day, so we can take the maximum of either of the 3. So ARR of 0, 0, and math.max of ARR 0, 1, ARR 0, 2. This should give us the starting point. Tabulation is bottom up. Bottom up means we are going from the base case to the answer that we want. So for this we're going to need a loop, the same loop that we use in memoization. Day 0, no, because for day 0 we have done, right, these base case values. So we'll start from day 1 and we will go up till n-1 day, and then on the particular day it depends on what task we did on the last day. So last would be 0, last less than equals to 4, last plus plus. Then on the particular day you would have to perform tasks, so that would be int task equals to 0, task less than 3, and task plus plus. right? So if our task is not the last task that we performed, then we can calculate the points. Points would be ARR of day. It's similar to what we did in memoization. Here, day task. Like we're performing this task. We're performing this task, so we are going to include that task's points, and then we are going to pass this same task to the next day, so that that day knows that I should not perform the task. But instead of F, we're going to use DP since we have the value stored now. Day minus 1, and we need to pass this task. And then what we can do is we can just use the maxi variable. We can declare it here. Maxi equals 0. Oh, we don't actually need maxi. We can directly use DP, right? Because we are trying to calculate this value. We're trying to calculate DP of day last. So we'll just assign it 0, and then whatever is the maximum value, we can just store it directly here instead of using a maximum variable. So DP of day last equals to math.max DP of day last and points. At the end of the day, we will have our answer stored in DP of n minus 1. How many days are there? 0. Tasks are 0, 1, 2, 3, so 4. This should store our answer. Let's see if we made silly mistakes again. Oh, we need to minimize this. What is this? Expected semicolon. Oh. I made a mistake somewhere. It says area index out of bounds. That means I made a mess of some index in some loop. So our DP array is fine. 0, 1, 2, 3. Last task is also fine. Then where is the mistake? Line number 48. Oh, we can't return the last index's value. My bad. We're not initializing here, we're returning a value. So it has to be 3. As you can see, the tabulation solution is working. Let me submit it. Still getting used to the trackpad. Yeah, the tabulation solution is working as well. Now we can stop here, since our time complexity, we have managed to reduce the recursion stack space. So the time complexity at the moment is order of big O of n into 4 into 3, right? And the space complexity is big O of, since we're using an n cross 4 array, that would be our space complexity. Now, can we reduce this? Can we reduce this space further? Because I don't think we can improve the time complexity. So the answer is that yes, we can improve the space complexity. That's because, as we can see, for calculating the points, the only value that we need is from the previous day, right? So instead of storing the entire DP array, right, we can just store the values of the previous row, because that's all we need to correct. That's all we need in order to calculate the current day's value, right? So instead of using a 2D array, we can use a 1D array of size 4, right? We can use a 1D array of size 4. Let's call it previous array, since it stores the values of the previous day. I must have pressed the insert key, that's why it's messing. Yeah, previous is new, and we can just throw these same values in a single 1D array. Right? And here, right, like in this place, instead of day minus 1, I can just use the previous array, right? And instead of this, what we can do is we can just use a temporary array, right? Like, we are calculating the current day's values, so we need to store it somewhere, right? And on the next iteration, this temporary array becomes the previous day for the next day. So we'll just use a temporary array of size 4 again, right? And we can just mention it here, since we are calculating temp of last. This becomes temp of last again, right? Now, once this iteration is over, right, like for the day, we have calculated all the values. What we can do is, for the next day, this the previous actually becomes this temp array, right? So this temp becomes the previous for the next day. That's what I'm saying. So at the end of the day, what we can return is previous of 3, because this will be storing the accumulated value. I mean, previously we were returning dp of n minus 1 and 3, right? It's the same thing. The last value in the array will store the accumulated maximum points. Let's try and run this. Again, 32. What is it? Cannot find symbol dp. Oh, this is temp of last. Temp of last. Let us submit the solution. Yeah, so the space optimized solution works as well, and this is as good as constant, right? So we are using just a 4 size array, so we have managed to reduce the space complexity from n cross 4 to constant. This is the most optimized solution using dynamic programming for this problem. So I guess we're done. The only mistakes we made were syntax errors, semicolons, brackets, right? That was because I was just trying to get used to code on stream. So I guess that is it for today. On another day, we will be solving another dynamic programming problem. So yeah, that is it. Hopefully someone was able to learn something. I sure did. These problems are always really interesting, and it's always fun to move from recursion to memoization to tabulation and tabulation, and space optimization. So yeah, hopefully I'll see anybody who joined the next time again. Happy New Year.